So after all these preliminary basic concepts that you need, we are here in the oceans. So the warming pattern matters. As we said, the poles are warming more. We will explain why that is in a little bit more detail, but as I said, you can already use your existing concepts of ice albedo feedback to see why that would be. There are other dynamic reasons. As I said, tropics are already warmed. If you try to warm them, they will convect more. Immediately there will be more evaporation and there is more rainfall, also droughts and so on and so forth. But getting back to the ocean, this is showing essentially an animation of ocean temperature. You can see that it's going from 1970 onwards, and it's blocked off the higher latitudes where either there is sea ice and not much ocean, or there is not enough data to do this properly. So this is showing here on the left the depths. So you look at, remember the difference between temperature and heat content, right? Temperature is of a particular layer, like sea surface temperature means some thin layer of the ocean, or the mixed layer, which is the bulk sea surface temperature. Heat content is the averaged amount of heat that's available over a depth, right? So this is showing various depths here from 0 to 10 meters, 10 to 100, 100 to 200, and then from 200 to 300. As you go deeper and deeper, the amount of data begins to become less and less. At the end, I will show some of the new technologies that are being proposed, developed, deployed, and so on, that are required to monitor the ocean. Monitoring the ocean is not easy. It's far away from land, deep, biological contamination or biofouling that we talked about in another context, and so on. So the main thing I want to point out here is that, of course, 0 to 10 meters, you can see the patterns that look somewhat like the El Nino type, La Nina type, and so on, and there is a spatial pattern to it. So the West Pacific, which is already warm, is showing more warming, especially when even from the surface to the depth. So 0 to 10 meter warm, 10 to 100 warmer, 10 to 200 much warmer, and then less below 200, right? So the dynamics of the ocean and the dynamics of the atmosphere together determine where the heat goes. Remember, the ocean can have two modes of taking up the global warming heat, right, from the atmosphere. If the atmosphere is warming in a certain pattern, there is a diffusion of heat that can happen from the surface, but that's a very slow process. So the dynamics work better. The regions where there is convergence and water is sinking, surface heat can go down, and regions where the winds are very weak and latent heat loss or evaporation is low, can work. Or there are regions where deep water is forming or thermocline water is forming, so the surface properties are being set and being sent below the surface. So I'm saying it in a kind of descriptive way because without looking at all the dynamics, it's hard to explain all those things, and we haven't done those kinds of detailed dynamics. But we will come back to the knowledge of thermohaline circulation and the subtropical gyres to understand where the heat is penetrating when we look at sections. Okay, here we are looking at averaged heat content, so 0 to 10 meters, 10 to 100, 100 to 200, and 200 to 300. So you can see the Gulf of Mexico region here is getting pretty warm. Maybe it has something to do with the heat being transported from the tropics. Gulf of Mexico has complicated patterns. You can see the patterns in the North Atlantic, North Pacific, Southern Ocean patterns. Indian Ocean has a complicated pattern. The northern Indian Ocean, north of about, let's say, 5 to 10 south, is quite warm at all depths, but there is a patch of cooling that happens here that is potentially related to the heat coming in from here. For example, if the Pacific is taking up heat here in the West Pacific, you can see that the Indonesian through flow is probably pumping that heat into the Indian Ocean. In fact, there is evidence that this happens, right? This not only happens through Indonesian through flow as a part of the thermohaline circulation, but can also happen when the ocean is gaining heat content from global warming. So the Indonesian through flow can then begin to take some of the excess heat into the Indian Ocean. And then the Indian Ocean has its own thermohaline circulation, deeper waters from the Antarctic Southern Ocean coming in, getting converted to surface water and going out, merging with the Indonesian through flow and going, remember the Agulhas retroflexion and the Agulhas outflow, right? So that's the main thing to remember, that the dynamics actually produces patterns of warming. It's not uniform warming everywhere, okay? Because it's slow moving, because it has heat content, because it has dynamics, this is what happens. What is happening also in terms of changes over the ocean? Ocean is a key factor in cyclones, hurricanes, typhoons, right? We saw this in one of the chapters when we were doing air-sea interactions. So ocean is the main source of energy. Lots of seeds of cyclones are being put in by convection, which is basically a cyclonic circulation, which is counterclockwise in the northern hemisphere. If there is ocean heat content available to feed the thirsty cyclone to grow into a monster, then it'll grow. So then the question is, with the warming patterns and with the increasing heat content, are the cyclones becoming more in number? Are they becoming more in intensity? Are they becoming more in duration? So all the evidence thus far is that warmer water definitely fuels hurricanes, and the Atlantic Ocean is having some rather severe years. 2005, as we saw, was a phenomenally strong hurricane activity. 2020 is a very strong year as well. They have already gone past the number of names they picked. They picked names for 21 storms, tropical depression storms, hurricanes. And when they run out of those names, then they begin to go into alpha, beta, and so on. So they already are into beta, which means they already have more than expected number of hurricanes this year. Okay, so the other thing that's very clear by now is that this warming of the ocean and the atmospheric changes together have created conditions where number of cyclones overall over the world is not significantly increasing. There is no evidence that they are significantly increasing, but the number of cyclones that are intensifying into category 4 and 5 is increasing. So again, remember, sea level rise, stronger hurricanes or cyclones and typhoons, bringing in more storm surge and inundation. And of course, wind and pressure damage associated with the hurricanes as well. There are lots of other details. Storms are moving slower in some sense, because if you increase the ocean heat content and the cyclone comes, energy is chewed up and the ocean cools. But if there is more heat content, then it doesn't cool as fast. So the cyclone moves slowly in a very simplistic sense. And there is something called rapid intensification. Cyclones are getting stronger by almost 55 kilometers per hour within 24 hours, which is very unusual. So more and more storms seem to be showing some signs of rapid intensification, which makes predicting hurricanes in its tracks a bit more difficult. Right? So you can see how things cascade into disasters. Changes in the ocean, obviously Gulf Stream, there is a large amount of heat being released to the atmosphere. Ocean water becomes cooler, denser, and then sinks, and we have the North Atlantic deep water. So if you increase the temperature here, you can potentially increase the evaporation, dense water formation, and so on. But if there is either more rain, or if the aerosols are blocking the heating, or glaciers are melting and putting some fresh water in the regions of deep water formation, then you can actually reduce the deep water formation, which means the heat transport northward can decrease. So remember the warming pattern. We saw that there was a hole in the warming in the North Atlantic. You cannot see it very clearly here, but somewhere here the cooling has persisted for a long time. So that has something to do with the thermohaline circulation and its response to global warming. In other words, you have to add many concepts together in your head to explain and to understand global warming. Okay, so ocean is warming, but the patterns are complicated related to dynamics. Warming ocean does affect hurricanes. Again, it's not just that the number of hurricanes will increase, but they can get more intense. Cyclones are becoming more, and they are intensifying rapidly. They are moving slowly. Near the coast also they hang around longer because there is more warm water, which means they dump more rain. There have been record-breaking rains associated with hurricanes Francis and Dorian, and the one that hit Houston, I forgot name, maybe Michael or whatever, right? All these things we have to worry about.